record. Okay, so for 7, so here's the deal. You're on a cliff, and you have a rock, and you throw it over. Here's the water, right? So remember, you want to do conservation of energy. Initial kinetic energy plus initial potential energy equals final kinetic energy plus final potential energy. We don't have to do any non-conservative because negligible of air resistance. You don't have to do the WNC thing. So no need. And remember, the W stands for work, not weight in this case, non-conservative work. So we don't need to worry about it. Now, of course, you have some speed initially, right? So 1/2 mv squared, or 15 squared. And there's potential energy because you're high above the water, right? So m times 9.8 times the height. And then it's going to have velocity when it hits the water, obviously, because they're asking for it. So 1/2 m, and you know it's 24.8, so we're actually going to plug in 24.8. And there's no potential energy because you're now on the water. You've defined potential energy as a height off the water. You're now on the water, so there's no more potential for any energy. So that's 0. Now all the m's cancel because you see m's for every term, so they all cancel. Keep moving. You have 1/2 times 225, and that's going to be 19.6, 196, I think, equals 1/2 times, I'm not going to do that in my head. So let's use a calculator here, use my cell phone. 24.8 times 24. Come on. I'm always not that great with this cell phone stuff. 615.04. If I divide that by 2, I get 307.52. And let me take care of the 1/2 of 225. Add to 196. It's close enough. It's not spot on, but it's close enough. So that proves it. My guess is they may have rounded some things a little too soon, but you're close enough. So that's how you would go about number 7. Or I would just ask, find me the final velocity. Then solve for, solve for this over here, and you should get something close to 24.8. So hopefully that makes sense. And again, this is being recorded, and I'll label these as well. So probably I would suggest maybe starting tonight, rewatching some videos, and then of course when you stand for the test Thursday night, that would help too, I think. Kind of watch this stuff again. Clear it. And then for number 6, okay, let me move this up just a tad. So you do have to convert the 110 kilometer per hour to meters per second. So probably just do that quickly, just get out of the way. Again, I'm going to go on my phone. I'm going to go on Google Chrome. And I am going to type in 110 km. And it already knows what I want. You can actually see my cell phone. It's kind of hard to see, but it says 110 kilometers per hour to meters per second. So it already knows what I want. Kind of smart, right? So it's 30 point, I'll probably be as accurate as I can, 30.556 meters per second. So again, you're on the ground, you're going up a hill. Here's the car. It's going up the hill. So again, initial kinetic energy plus initial potential energy equals, excuse me, final kinetic energy plus final potential energy. And again, right now, friction is negligible. So no WNC. Don't need to worry about non-conservative work. So again, you have 1/2 mv squared, or 30.556 squared. You have no potential energy right now because we defined potential energy as height off the ground from the bottom of the hill. I would be more clear with my assumptions so you guys can, don't worry about that. Near at the top, you come to rest. So I would also be clear about that too. At the top of the hill, so say 0 plus mgh, m times 9.8. And we're trying to solve for the height, right? Yeah. Fortunately, the m's canceled. That's going to happen often with these calculations here. So that's why you don't need to know m. So you're doing half of that junk there. So 30.556, 30.556 plus 30.556, 933.669. Divided by 9.8. So 47.636, which is right what we get there. So it always feels good when you get the answer that matches up, right? We feel confident we got this. Then what you have to do for part B is take into account thermal energy. So you do have to take into account. So we're going to do roughly the same thing. I'm solving for WNC. And also, I can't cancel out the masses like I did. So I'm going to make a little adjustment here. $750 and 750 kilograms. And the height I also know is going to be 22. So your WNC is going to equal 750 times 9.8 times 22 minus 1/2 times 750 times 30.556 squared. So again, you're just going to plug and chug, just plug all this junk into your calculator. So 750 times 9.8 times 22. So I got 161,700. I will need my charger because it looks like my laptop's about that. 750 times 0.5 times 30.556 times 30.556. Pretty big number there. 350,125.926. So I'm doing 161,700 minus roughly 350,125. So do you get about negative 188.425 or 425,000 joules? Or we say times 10 to the 5th because you have to move it over. Let me write that more neatly. You take a decimal point, move it 1, 2, 3, 4, 5 places to the left. And it's negative because it's friction, right? So that's how you do part B. Now you have the answer for part B. Nope, that was my cell phone falling on the ground. That was gravity. Hope I didn't crack the screen. Then what you need to do, find the average force due to friction. So the work due to friction, again, was 1.89. I mean, it's really negative, but whatever. Q positive. And then remember, work is force times distance, right? Let me actually write that more neatly. Work, our work is this. We want to find the force that's asked for. In the distance, you're traveling up a hill that's I wonder, I think we use the height over here, actually, 22. They should be more clear about that also. The sine of 2.5 degrees equals 22 over d. If you move things around carefully, these going to be 22 over sine of 2.5 degrees. And then you bring that over here. Okay, do you need my cell phone? Let me grab it really quickly here. So let's see. So remember, I got 25 divided by parentheses sin 2.5. So you should get about 573 1.14 meters. Now I got to do 189,000 divided by that, 189 divided by 573. Yeah, it's a little off, actually. I wonder why it's off. Maybe they were using the other height. I don't know, but I'm just going to go with what I have here. I have 329.76 joules. Not sure where the 375 came from. Maybe I made a mistake somewhere if someone could catch it. Yeah, because you're taking the work due to friction. Anyway, but that's the calculus you should be doing. I don't know why the answer's off a little bit.
Mr. E.
Yeah, did I make a mistake? Did you catch it? Good.
I did 22 divided by sine of 2.5 degrees, and I got something else.
So I may have made a mistake. Let me look at my calculator again. Maybe I was in the wrong mode. I'm in degree mode. So let me do 22 divided by parentheses sine 2.5. You are right. How did I? Sheesh. I have no idea. I got 573. So that stuff happens. That's why you show your work. So you get most of the credit. So now let me try that again. 109,000. 375. Yeah, usually you should trust these textbooks because they do have a lot of editors. I'm just one person. I can make mistakes. Yeah. Oh, not meters, duh. Newtons. Thank you for correcting me on that mistake. Okay, so now what we're going to do is we're going to talk about power before we do a break. So let me, and